Thank you for being here today. I'm excited to talk to you about a topic that affects us all: how we eat, how it shapes our bodies, and how we can use the science of nutrition to unlock better health, burn fat, and build lean muscle. But before we dive into meal plans or macros, let me reframe things. I want to talk about style, not fashion, but the style of how we eat. Because how we fuel our bodies says more about us than we realize. So today, I'll share the 5 signs of style habits that reflect a scientifically sound, results-driven approach to nutrition. Eating is one of the most fundamental behaviors we engage in. It influences our energy levels, our ability to focus, how we recover from exercise, and even our emotional states. While most people view food primarily through the lens of calories or dieting, a more effective and science-supported approach is to think of eating as a behavior governed by systems in the brain and body that can be shaped and optimized by intention. At the neural level, what we choose to eat and when we eat are influenced by several circuits in the brain, particularly in the hypothalamus, which integrates signals related to hunger, satiety, and energy balance. But beyond this homeostatic control, the regulation of internal conditions, there's also hedonic eating, which is driven by the brain's reward circuitry, particularly the mesolimbic dopamine system. This system doesn't just respond to the presence of food, it responds to anticipation, meaning that our thoughts and context around food can significantly influence how much we eat and what we crave. This is where mindful and purpose-driven eating becomes crucial. When you eat with a specific goal, whether it's to enhance cognitive function, improve physical performance, lose fat, or build lean muscle, you're activating the prefrontal cortex, the part of the brain involved in planning, decision making, and self-regulation. Simply put, being intentional engages brain regions that can help override impulsive or emotionally driven food choices. Research supports that when people practice mindful eating, that is, paying full attention to the taste, texture, smell, and even the appearance of food, they experience increased satisfaction and reduced tendencies to overeat. This is partly because mindfulness strengthens interoception, our ability to perceive internal signals like fullness and hunger. The more accurately you can detect these signals, the better you can regulate your intake without relying on external cues like calorie counts or meal timing rules. From a physiological perspective, eating with intention can also align your food intake with your circadian rhythms, which influence metabolism. For instance, insulin sensitivity is higher in the morning and earlier part of the day, meaning the body processes carbohydrates more efficiently during those times. Aligning your carbohydrate intake with these rhythms can improve energy levels and support fat loss goals. Moreover, if your goal is to gain lean muscle, eating protein, rich meals deliberately timed around resistance training can enhance muscle protein synthesis. Studies show that consuming around 20-40 grams of high-quality protein within a few hours after training significantly improves recovery and hypertrophy. This timing and quantity are examples of how intentional eating, guided by scientific understanding, can directly influence your physical outcomes. It's also important to recognize how emotional and environmental triggers impact our eating behaviors. Stress, for example, elevates cortisol, which can drive cravings for high-sugar, high-fat foods. Intentional eating involves becoming aware of these triggers and using structured behaviors such as preparing meals in advance, avoiding food shopping when stressed, or creating specific eating windows to minimize impulsive decisions. One useful practice for cultivating this intention is meal journaling. Not just tracking calories, but noting how different meals make you feel physically and mentally. Over time, this builds a feedback system that teaches you how specific foods support your goals, whether that's sustained energy, reduced bloating, improved focus, or better sleep. This is a form of behavioral conditioning. You're essentially teaching your brain to associate healthy choices with real-time benefits, which reinforces the behavior without needing external pressure or restriction. In short, purposeful eating isn't about restriction or rigid discipline. It's about aligning your food choices with a clearly defined outcome and using both science and self-awareness to guide those decisions. When you shift from reactive eating, driven by cravings, convenience, or emotion, to proactive, goal-aligned eating, the results compound. You become more in tune with your body, more resilient in the face of temptation, and more empowered in your health and performance. Eating then becomes a tool not just for body composition or weight management, but for daily function, emotional regulation, and long-term vitality. When done with purpose, it activates the very neural systems responsible for self, mastery, and forward momentum. And that's a style of living worth cultivating. One of the most impactful and overlooked ways to influence your physical energy, cognitive performance, body composition, and long-term health is through the regulation of macronutrients, that is, proteins, carbohydrates, and fats. While the popular conversation around nutrition often veers into trends like low-carb or high-fat diets, the real utility lies in understanding how each macronutrient affects the brain and body, and then deliberately adjusting those ratios in alignment with your specific goals, such as fat loss, muscle gain, or metabolic health. To begin, protein is arguably the most essential macronutrient when it comes to rebuilding tissue, particularly muscle, and supporting neurotransmitter synthesis in the brain. Proteins are made up of amino acids, and 9 of those amino acids are essential, meaning they must be consumed through the diet. When we consume high-quality protein sources, such as eggs, fish, meat, and certain dairy or plant-based options, we provide the raw material for muscle repair, enzymatic function, and the synthesis of dopamine, serotonin, and other key neurochemicals. There's compelling research showing that a higher protein intake, typically ranging from 1.6 to 2 grams of protein per kilogram of body weight, supports lean muscle preservation during fat loss and enhances muscle protein synthesis when combined with resistance training. From a behavioral standpoint, protein also increases satiety by influencing gut-brain signaling through the vagus nerve and the release of hormones like GLP-1 and peptide Y, which send signals to the brain to stop eating. This is why increasing protein intake often naturally leads to a reduction in overall calorie consumption. Carbohydrates, on the other hand, serve as the primary energy source for high-intensity exercise and brain function. Glucose, the simplest form of carbohydrate, is the preferred fuel for the central nervous system. Inadequate carbohydrate intake over time can impair cognitive performance, reduce training intensity, and dysregulate mood due to alterations in serotonin synthesis, which is highly sensitive to glucose availability. However, carbohydrate timing and type matters significantly. Complex carbohydrates, such as oats, quinoa, sweet potatoes, and legumes, offer a slower release of glucose and are less likely to spike insulin dramatically. These types of carbohydrates support sustained energy and metabolic stability. In contrast, simple sugars can create rapid increases in blood glucose and insulin, followed by a steep drop, which can lead to fatigue and cravings. This blood sugar roller coaster is mediated in part by insulin's interaction with the hypothalamus, a brain region that helps regulate energy intake and expenditure. There is a time and place for digesting carbs, notably post-exercise, when the body is more insulin-sensitive and primed to replenish glycogen stores. This strategic use of carbohydrates is one example of how macronutrient balance isn't static, but should adapt based on daily activity and physiological demands. Fats are equally essential, particularly for hormone production, cellular health, and brain function. The human brain is nearly 60% fat by dry weight, and it relies on essential fatty acids such as omega-3s, DHA, and EPA for optimal function. These fats are not just structural, they actively influence neuroplasticity, inflammation, and neurotransmitter receptor sensitivity. Diets that are too low in fat can lead to mood instability, reduced cognitive function, and hormonal imbalances, particularly in men and women engaged in intense training or under caloric restriction. Healthy fat sources, including avocados, nuts, seeds, olive oil, and fatty fish, help regulate the release of leptin, a hormone that signals satiety to the brain. Moreover, consuming fat with meals slows gastric emptying, providing more sustained energy and supporting blood sugar stability. However, dietary fats are calorie-dense, and excessive intake, particularly of saturated or trans fats, can contribute to systemic inflammation and poor cardiovascular health. The key is ratio and quality, not elimination or excess. What's critical to understand is that no single macronutrient is inherently bad or good. Instead, their value depends entirely on the context, your energy expenditure, your training volume, your sleep quality, your goals, and even your age. This is why rigid diet identities like keto, paleo, or vegan can sometimes obscure the science of nutrition. The body is a dynamic system, and macronutrient needs are best viewed as adjustable levers, not fixed rules. In sum, by learning how to consciously balance macronutrients, you create a system that supports not only your aesthetic goals, but also your mental clarity, emotional regulation, and physical performance. You train the nervous system to operate more efficiently by aligning internal biochemistry with external behavior. And this kind of informed, adaptive eating style becomes a foundation not just for looking better, but for functioning better in every domain of life. When it comes to health, fat loss, and building lean muscle, one of the most powerful principles is also one of the most misunderstood: consistency. In a world dominated by short-term diets, dramatic transformations, and all-or-nothing approaches, consistency is often undervalued. Yet, from a biological and behavioral standpoint, consistency is what drives adaptation in the brain and body. Biological systems, particularly those involved in metabolism, muscle growth, and neural plasticity, do not respond well to erratic input. The body is designed to adapt to patterns over time. For instance, if you eat nutrient-dense meals consistently, your body will upregulate enzymes and hormonal systems that optimize digestion and nutrient partitioning. If you train regularly, muscle tissue adapts by growing stronger and more efficient. The nervous system reinforces these patterns through long-term potentiation, the repeated firing of neural circuits that strengthens connections and makes behaviors more automatic. However, extreme diets or training regimens often create too much stress, not just physically, but neurologically. Cortisol levels spike, sleep quality declines, and homeostatic balance is disrupted. These conditions impair metabolic health and make it harder to sustain muscle mass, lose fat, or maintain energy. The brain, particularly regions like the amygdala and prefrontal cortex, begins to associate these behaviors with stress rather than benefit, increasing the likelihood of abandonment. Instead, consistency leverages a more sustainable model rooted in behavior change science. Habits, at the neurological level, form through the process of repetition and reward. The basal ganglia, a set of brain structures responsible for habit formation, respond not to perfection but to predictability. When you repeatedly engage in health-supportive behaviors, e.g., prepping meals, training at the same time each day, or going to bed consistently, these actions become more automatic and require less conscious effort over time. From a physiological perspective, consistency creates metabolic momentum. For fat loss, it allows your body to gradually shift fuel preference towards stored body fat, particularly when you're eating in a slight caloric deficit over an extended period. It also supports leptin and ghrelin regulation, the two hormones most responsible for hunger and fullness. Without consistency, these hormonal systems never stabilize, which is why extreme diets often lead to intense hunger or rebound weight gain. Muscle gain, too, depends heavily on progressive overload applied consistently. Sporadic training or random meal timing can disrupt muscle protein synthesis, which is most effective when the body receives regular signals through both resistance training and adequate protein intake. The mTOR pathway, a key regulator of muscle growth, responds best to reliable stimulus rather than sporadic or maximal loading. That's why missing workouts or skimping on protein intermittently can significantly hinder progress, even if overall training volume appears high. Sleep and circadian rhythms also play a vital role in body composition, And again, consistency is key. Sleep affects insulin sensitivity, cortisol rhythms, and growth hormone secretion, all of which impact how your body uses food and builds muscle. Going to bed and waking up at consistent times supports the natural rhythm of melatonin and cortisol, which in turn improves recovery, appetite regulation, and emotional resilience, three things that dramatically influence dietary discipline and training performance. Behaviorally, consistent routines reduce decision fatigue. When meals, training, and sleep are structured into your day, you free up cognitive bandwidth. This makes it easier to maintain discipline during moments of stress or temptation. It also reduces reliance on willpower, which is a limited and often unreliable resource. Instead of constantly debating whether to work out or what to eat, consistency turns these choices into reflexes. The reward circuits of the brain begin to associate routine with stability and positive outcome, reinforcing the habit loop. Importantly, consistency doesn't mean rigidity. Life includes social events, travel, and unexpected stressors. A consistent approach is one that allows for flexibility without collapsing entirely. This is often referred to as the 80/20 rule, maintaining healthy habits 80% of the time while allowing 20% for real life variation. From a neural standpoint, this balance helps prevent the burnout that often accompanies perfectionism. It keeps dopamine levels healthy by maintaining a sense of progress without chronic pressure or deprivation. In the long run, the body doesn't respond to extreme efforts made in short bursts. It responds to manageable actions repeated over time. That's where real change happens, at the intersection of biology and behavior, where small, sustainable practices reshape not just your physique, but your identity. The science is clear. Consistency creates the conditions for physical adaptation, metabolic efficiency, neural reinforcement, and psychological resilience. If your goal is to eat for health, fat loss, or lean muscle, then daily decisions matter far more than dramatic gestures. And when those daily decisions align with long-term goals, you create a system that the body trusts and ultimately transforms through. The human body and brain function best when supported by the nutrients they evolved to process. Nutrients found primarily in whole, minimally processed foods. Whole foods are those that remain close to their natural state. Vegetables, fruits, legumes, whole grains, lean meats, fish, eggs, nuts, seeds, and healthy oils. These foods contain not just calories, but a broad spectrum of micronutrients, fiber, enzymes, and bioactive compounds that support cellular health, metabolic balance, and neural function. When we eat whole foods consistently, we provide the body with the raw materials required for proper hormone production, neurotransmitter synthesis, immune system function, and tissue repair. This has a compounding effect, not just physically, but also cognitively and emotionally, because the body is not compartmentalized. What happens in the gut, for example, influences the brain through the gut-brain axis, particularly via the vagus nerve and microbial metabolites that signal to the central nervous system. One of the most direct benefits of a whole food diet is its impact on inflammation. Chronic, low-grade inflammation is associated with numerous health conditions, including obesity, insulin resistance, depression, and neurodegenerative diseases. Whole foods, particularly those rich in antioxidants, like berries, leafy greens, cruciferous vegetables, and omega-3 rich fish, help regulate inflammatory pathways by reducing the production of pro-inflammatory cytokines and oxidative stress markers. On the other hand, diets high in ultra-processed foods, which are typically high in added sugars, refined seed oils, emulsifiers, and artificial preservatives, have been shown to increase systemic inflammation and disrupt the gut microbiome. These foods are engineered to be hyper-palatable, overstimulating the brain's reward circuitry, especially dopamine pathways in the nucleus accumbens. This makes it harder to regulate portion size and can lead to cycles of overeating and withdrawal, similar to patterns observed in addictive behaviors. Whole foods also support glycemic stability. Unlike refined carbohydrates, which are digested quickly and lead to rapid spikes in blood glucose and insulin, whole carbohydrates like oats, quinoa, lentils, and sweet potatoes are digested more slowly due to their fiber content. This slows glucose absorption, promotes satiety, and helps maintain stable energy levels, all of which are essential for physical performance and cognitive endurance. Fiber, particularly soluble fiber found in vegetables, fruits, and legumes, plays an essential role in supporting metabolic and gut health. It feeds beneficial bacteria in the colon, producing short-chain fatty acids SCFAs like butyrate that help regulate inflammation, improve insulin sensitivity, and even influence mood via serotonin pathways. SCFAs also play a role in strengthening the gut barrier, preventing endotoxins from entering the bloodstream, a condition linked to systemic inflammation and impaired immune function. From a muscle-building perspective, whole foods are essential because they provide not only macronutrients, but also micronutrients like magnesium, zinc, iron, and B vitamins, all of which are required for muscle contraction, recovery, and protein synthesis. For example, magnesium is involved in over 300 enzymatic reactions in the body, many of which relate directly to energy production and recovery. A deficiency in these minerals, common in individuals consuming mostly processed foods, can blunt performance and recovery even when protein intake is adequate. Eating whole foods also modulates hunger hormones in a way that supports fat loss. For example, protein-rich whole foods like eggs, chicken, tofu, and Greek yogurt stimulate the release of peptide Y and GLP-1 hormones that signal fullness to the brain. Similarly, fiber-rich foods enhance the stretch receptors in the stomach and delay gastric emptying, which further amplifies satiety signals. This hormonal feedback loop reduces cravings and lowers the overall caloric load without requiring strict calorie counting. Whole foods have another advantage. They teach the brain to associate eating with real physiological outcomes rather than emotional gratification. Over time, the palate adapts. Neuroplasticity, the brain's ability to reorganize itself in response to experience, applies here. As you consistently consume whole foods, the dopamine system begins to associate those foods with positive outcomes: better energy, improved mood, enhanced performance, and reduced discomfort. This retrains the reward system to prefer health-supportive behaviors. It's also important to recognize that whole food eating isn't about purity or moral judgment. It's about function. The goal is not to be perfect, but to eat in a way that supports physical and cognitive performance. Occasional indulgences are not damaging in the context of a consistently whole food diet because the system remains resilient. What matters most is what you do most of the time. Ultimately, eating whole foods regularly provides the body and brain with the tools to perform, adapt, and thrive. It supports the feedback loops between the gut, hormones, and brain that regulate energy, mood, focus, and recovery. And it does so not through extremes or restriction, but through aligning your internal biology with the types of inputs it was built to process, a system rooted not in hype, but in biology. Evolution and measurable outcomes. Food is one of the most powerful forms of biological input we have. Every meal sends a chemical and electrical signal throughout the body, impacting hormones, neurotransmitters, and gene expression. Yet, for many people, food has become disconnected from this scientific reality. It is often used as a tool for emotional regulation, a source of shame, or a mechanism of punishment, especially in the context of body image or performance goals. Reframing food as fuel rather than as a form of reward or punishment is not only psychologically beneficial, but it is also scientifically grounded in how the brain and body respond to nourishment. When food intake is aligned with physiological needs, it optimizes performance, recovery, and mental clarity. When food is restricted or emotionally charged, it can dysregulate the neural circuits responsible for hunger, stress, and behavior control. The brain's regulation of appetite is not purely logical, it is deeply tied to the limbic system, particularly the hypothalamus and amygdala, which integrate emotional cues with physiological. Hunger, when food is used to punish, for example, skipping meals to make up for overeating, it disrupts this balance. Chronic undereating or inconsistent fueling triggers elevated cortisol and reduces leptin and insulin sensitivity. Over time, this leads to increased cravings, especially for high-energy, low-nutrient foods due to survival mechanisms encoded in our biology. In contrast, when food is approached as fuel, eating becomes a deliberate act that supports homeostasis and enhances function. For instance, eating adequate carbohydrates post-exercise replenishes glycogen stores in muscles and liver, supporting energy availability for subsequent physical or cognitive tasks. Similarly, adequate protein intake, distributed evenly throughout the day, supports muscle protein synthesis and repairs tissues damaged during training, while also supporting neurotransmitter function. A fuel-first approach also respects the neurochemical relationship between food and brain state. Tryptophan, for example, is an amino acid found in protein, rich foods that serves as a precursor to serotonin. Omega-3 fatty acids, found in fatty fish and certain seeds, enhance the fluidity of neuronal membranes and regulate dopamine pathways. These nutrients are not just healthy. In a general sense, they play direct roles in regulating mood, focus, and motivation. Using food as fuel ensures the brain is given the tools it needs to operate efficiently. Crucially, this reframing helps disengage the brain's stress response system from eating. When people restrict food intake or oscillate between binging and compensatory behaviors, the body often enters a state of perceived scarcity. This activates the hypothalamic, pituitary, adrenal HPA axis, increasing cortisol. Elevated cortisol not only breaks down muscle tissue and impairs sleep, but it also interferes with decision-making circuits in the prefrontal cortex, making long-term planning and self-regulation more difficult. This is often why cycles of dietary restriction backfire, not due to lack of discipline, but because the brain is operating in a survival state. In contrast, fueling the body consistently and strategically enhances what psychologists call executive function. The ability to make long-term, goal-oriented decisions even in the presence of short-term temptations. From a neuroscience standpoint, this involves strengthening the prefrontal cortex's control over limbic impulses. When the body is well nourished, blood glucose remains stable, neurotransmitters are balanced, and there is less noise in the system. This allows for greater self-regulation, not because of increased willpower, but because the biological foundation for decision-making is more stable. This also has powerful implications for emotional health. Many people experience guilt or anxiety around food because of deeply ingrained cultural messaging. But the nervous system responds to food predictably, not morally. There's no such thing as a good or bad food in isolation. There are foods that support your goals more directly, and foods that may need to be consumed in moderation based on metabolic response or training demands. When food is treated as functional input, not moral currency, the psychological burden is reduced, and people tend to make better, more sustainable choices. That said, fueling the body doesn't mean ignoring pleasure. The brain is wired to associate food with reward, taste, texture, even social connection. That's not a flaw, it's a feature. Enjoying food, especially in a mindful, intentional way, actually enhances satiety by engaging the full sensory and emotional circuitry of the brain. The key distinction is whether that reward is aligned with physiological needs or compensating for unmet emotional ones. Ultimately, using food as fuel reorients your relationship with eating from a reactive behavior to a strategic one. It respects the biology of the body and the psychology of behavior. It puts you in a position of agency, making informed, supportive decisions that enhance performance, recovery, and well-being. Over time, this shift becomes self-reinforcing. when you eat to function better and you feel the results: clearer thinking, stronger workouts, better sleep. Your motivation is driven by feedback from your own nervous system, and that's when food becomes more than fuel. It becomes a tool for empowerment. One of the most crucial principles in nutrition, yet one of the most underutilized, is personalization. While popular media tends to offer sweeping generalizations, eat more protein, cut carbs, intermittent fasting is optimal. The reality, grounded in both biology and neuroscience, is that optimal nutrition is deeply individual. Our genetics, activity levels, age, sex, sleep patterns, stress levels, and even time of day all influence how the body and brain respond to food. The central nervous system, particularly the hypothalamus, integrates signals from the body about nutrient status, energy availability, and metabolic need. These signals, including hormones like leptin, ghrelin, insulin, and cortisol, vary widely from person to person, and even within the same person depending on environmental context. What this means is that a fixed dietary protocol will not generate consistent outcomes across individuals. For instance, two people can eat the same amount of carbohydrates and experience entirely different responses. One may see stable glucose levels and a clear cognitive boost, while the other may experience fatigue, irritability, and a rapid blood sugar spike followed by a crash. This variation isn't anecdotal, it's physiological. Postprandial glucose responses, how your blood sugar responds after eating, are now known to be highly individualized, influenced by gut microbiota composition, insulin sensitivity, circadian rhythm, and even the speed at which food is digested and absorbed. Recent studies using continuous glucose monitors, CGMs, have shown that even among healthy individuals, responses to the same food can differ by 300–400%. This highlights the need for an evidence-based approach that adapts to your specific biology rather than relying solely on population-level guidelines. Beyond blood sugar, protein requirements vary depending on training intensity, age, and recovery status. While many athletes or physically active individuals benefit from 2 grams of protein per kilogram of body weight per day, someone recovering from injury, experiencing hormonal shifts, or undergoing caloric restriction may need to adjust that range. Similarly, fat intake, often broadly categorized as healthy or unhealthy, requires context. Certain individuals respond well to higher, fat, lower, carb diets due to genetic markers related to lipid metabolism or insulin function. Others may see elevated triglycerides, brain fog, or reduced training performance. Personalization also applies to nutrient timing. The timing of food intake in relation to circadian rhythms, exercise, and sleep affects how nutrients are utilized. For example, consuming carbohydrates earlier in the day, when insulin sensitivity is naturally higher, supports better glucose disposal and energy levels. Conversely, training in a fasted state can benefit fat oxidation for some individuals, but may impair performance or increase stress in others, particularly if sleep is inadequate or cortisol levels are already elevated. This is where personalization intersects directly with neuroscience. The brain thrives on predictability and adaptation. Once the nervous system recognizes patterns in nutrition and energy availability that align with physical demands, it shifts into a state of efficiency. Neuroplasticity, the brain's ability to change in response to behavior, plays a role here. As you feed the body in a way that supports stable energy, mood, and recovery, the brain reinforces those habits by associating them with positive outcomes. This strengthens neural pathways in the prefrontal cortex responsible for planning and goal setting, reducing reliance on willpower and increasing adherence. Personalized nutrition also helps regulate the stress response system. One-size-fits-all diets often fail because they increase internal friction, the feeling that your eating pattern is in conflict with your lifestyle, preferences, or physiology. This internal mismatch elevates cortisol, reduces compliance, and undermines both metabolic and psychological resilience. In contrast, a personalized science, backed approach lowers friction by aligning biological need with behavior, making nutrition feel like support rather than restriction. The emerging field of nutrigenomics, the study of how individual genes interact with dietary components, further underscores the importance of personalization. Some people carry gene variants that affect how they metabolize caffeine, how efficiently they process saturated fat, or how strongly they respond to certain vitamins. While this area is still developing, it reinforces the principle that no two people require exactly the same inputs to achieve optimal function. What's powerful about a personalized, evidence-based approach is that it shifts nutrition from being reactive to proactive. Instead of following rules and hoping for results, you're gathering data from biomarkers, wearables, subjective experience, and performance feedback and using it to fine-tune a system. This creates a loop of observation, action, and refinement, which not only improves outcomes but also builds trust in the process. Ultimately, science-backed personalization isn't about complexity, it's about precision. It respects the fact that the human body is an adaptive system, not a machine. When you align your nutrition with your biology, your environment, and your goals, you remove guesswork. You transform food from a variable into a lever, one that you can adjust with accuracy to improve not just body composition, but cognitive clarity, emotional resilience, and long-term health.